I'll be explaining regarding the dehumidifying procedures or the processes that we are using in the HVAC. See, dehumidification is required or not, that is totally depending upon the climate condition and the space condition only. Whether that is comfort air conditioning system or if it is industrial or precision type air conditioning system. So as I told, like dehumidification is not mandatory always. Sometimes winter time it might not be mandatory. In summertime we might be required it. So that is totally dependent with respect to the climate data and the space condition. And dehumidification, we are using like various methods. For most of the like comfort air conditioning systems, means like if we are proposing the air conditioning systems to provide comfort for the human, and also like our relative humidity is varying between like a 40% to 60%. Most of the times we will be using like a cooling coil based dehumidification only. Means the cooling coil will be doing it. The surface temperature of cooling coil we will be maintaining less than the dew point temperature of a space humidity ratio, and we will be achieving the humidity ratio. Once it has reached to the room condition, we will be reaching the required relative humidity. So it might be a coil based. The coil might be a DX coil, means the refrigerant based DX coil, or it might be a chilled water coil we can use for a coil based dehumidification. And not only that, we will be having for industrial applications, and even if the relative humidity sometimes you might be required like 5% or 10% or 20%, much lesser than this condition. In industrial applications and all, like especially in clean rooms, pharmaceutical industry, if you need very less relative humidity in certain spaces, there we might be using like a desiccant wheels. Means like desiccant wheel will be using. Desiccant wheel we might be using silica gel or molecular sieve. Okay, membrane type is also available. No? Means like air we will be circulating or permeating through the membrane. Accordingly, also the dehumidification is possible. Okay, so like as I told, most of the comfort air conditioning system, it might be like a coil based dehumidification only, and sometimes it might be for industrial application we might be using desiccant wheel. Okay, anyhow, if the relative humidity requirement is too less, most of the time we will be using desiccant wheel. Even if in comfort air conditioning system, like if you're having a 100% FHU or dedicated outside air system, means if you are having a dedicated equipment, air handling unit for the particular space or the building, then in that scenario, we will be using like sometimes if the requirement of fresh air handling or the requirement of fresh air has to be conditioned is very high, there also we might be using like a desiccant wheel. Okay, anyhow, there is, for example, if in this industrial application, as you know, if the relative humidity requirement is too less, like a 5%, 10% and all, the surface temperature of cooling coil you have to keep very less. So in that scenario, the coil load you need very high, no? The ton of refrigeration that you need for your cooling coil will be very high. That is not energy efficient. That's why in certain application we might be using desiccant wheel. So whether the desiccant wheel or the coil based is required or not, whether that is in comfort condition or in industrial application, that is with respect to the energy efficiency only we will be finalizing it. But just as a general rule of thumb, I told most of the comfort air conditioning application we might be using like a coil based dehumidification. Industrial application we might be going for desiccant based. Okay, anyhow, whatever it may, we might be selecting the dehumidifier with respect to the amount of water it has to be condensed or removed. For example, each hour, how much gram of water has to be removed, or how much kilogram of water has to be removed, how much quantity of water has to be removed. Based on that only, if it is a coil based dehumidifier or if it is a desiccant based dehumidifier, we will be selecting. Okay, how to do this, do that calculation, I will be explaining now. We can discuss in this session. Okay. For that, we need a psychrometric chart to explain it. Okay, I have taken like this is a same metric based psychrometric chart only. I have taken from Ashray. Actually, if anyone they have already watched the psychrometric sessions before, these things I have explained, but in one another way in a previous session. Okay, so we are having a certain condition where the dehumidifier will come. For example, if you are having a fresh air handling unit. Okay, so like the atmospheric air might be entering through this side. Initially, you might be having like a few set of filters will be there. Okay, like different F7 filter, grade 7 filter, no, G4 filter, different filters will come. And after that, sometimes he might be having a desiccant wheel. Okay. So if it is a coil based one, or if it is a desiccant wheel, hybrid type, combined systems also can come. So the air will be entering, then the desiccant wheel will be removing the required water, and after that it will be reaching to the cooling coil. Okay, we will be having certain fan and all, then it will be reaching outside certain another filters also will come there. That is conditional. Anyhow, I am not going to explain all those things. Okay, and sometimes after the coil also it can come. In hybrid system after the coil also it can come. In normal cases, the desiccant wheel will be removing the necessary moisture, and after that it will be reaching to the cooling coil. Cooling coil will be cooling the air until the room condition, then we can deliver it. But in hybrid system, after the cooling coil also it can come. Anyhow, we can discuss that. See, let me select few conditions. For example, I'm having nearly 2,100 CFM of air has to be distributed within a space. How this 2,100 CFM we will be getting? This one I have taken just for the explanation. Normally, when you are working in a comfort air conditioning system, if you are following ASHRAE standard from ASHRAE 62.1, RARP value we will be calculating, means people ventilation, area ventilation we will be calculating, and we will be adding, and we will be finding it. I have explained this in the HAB session. It is available in our channel itself. Okay. And if it is an industrial air conditioning method, if it is like a 4 ACH with respect to the air changes per hour method, if it is 4 ACH or 6 ACH, with respect to the ACH also we can calculate it. Anyhow, this is a condition that we required. 2,100 CFM of air will be entering into the machine at 35 degrees Celsius ambient of dry bulb temperature and 60% relative humidity. And it will be leaving the cooling coil, and this is an indoor condition that we require. 24 degrees Celsius dry bulb temperature and 50% relative humidity. And how much quantity of water has to be removed from the air? That is the dehumidifier capacity that we need to calculate. Very simple procedure. First, we have to plot this one to the psychrometric. 3560. Okay. So like 35 degrees Celsius dry bulb temperature and 60% relative humidity. That's a condition, right? Okay. 31, 32, 33, 34, 35. This is 35. 35, and this is 50%, and this is 60%. Correct. 35, 60. 31, 32, 33, 34, 35. This is a 35 line, and this is 60% relative humidity. That's a point. Okay. And what's indoor condition? 2450. You can see the alignment circle. 24 degrees Celsius dry bulb temperature and 50% relative humidity. So this is our indoor condition. And I'm not checking any enthalpy now because I'm not sizing the cooling coil. Rather, I am sizing the humidifier only. So like what is the humidity ratio of outside condition? Let's see. This is the humidity ratio of outside condition. How much it can come? See, like this is 20, 20.5, 21, 21.5, 22 gram of water. Each kilogram of dry air, how much grams of water it is accommodating? No, that is called humidity ratio. 20, 20.5, 21.5. So I'm finding it. Humidity ratio at entering condition, 21.5 gram of water per kg of dry air. Okay. This is a coil entering condition or the dehumidifier entering condition. What's the leaving condition? 24. And check the humidity ratio of this condition. Check it. That will come, okay, 8.5. Correct. 8.5, 9. This is 9.5, and this is 10 only. So that is coming between 9 and 9.5. You can consider like a 9.3 for before I told 9.8. No, like 8.5, 9, 9.5. Even if you are considering 9.5, that is fine. 9.3 I will be considering. 9.3 gram of water per kilogram of dry air. Okay. And see, now you can see from each kilogram of air, 21.5 minus 9.3, nearly 12.2 gram of water has to be condensed or removed from each kilogram of dry air. 1 kilogram. But psychrometric chart is for unit mass of air only. This is for unit mass only per kilogram. But how much amount of or how much kilogram of air that we are dealing, based on that we have to multiply this with. This 12.2 is the amount of water has to be removed from each kilogram of atmospheric air or dry air. So we have to multiply this value with our mass. We know this equation, like what density is equal to mass by volume, correct? Density of air is equal to mass divided by volume. Mass of air, if you know the mass of air, then we can multiply that value with this one, means that 21.5 minus 9.3, then we can find the water to be removed, correct? We know the airflow rate in CFM. Mass is equal to density into volume. Volume we can calculate from this equation. Volume is in meter cube per second. Density of air, for easy calculation, you can consider 1.2 kilogram per meter cube as standard temperature and pressure. But if you want to accurately consider, you can do that. Anyhow, first we need to find the volume. Okay, airflow rate. We are having that in CFM only. Like we can convert that in liter per second. So CFM divided by 2.119, we can convert that in liter per second. Liter per second divided by 1000, we can convert that in meter cube per second. So this is one. So we got the airflow rate. We got. Okay, how much it is? 0.991. Now you can multiply this value with the density 1.2. You can find the mass of air. That mass of air, you can multiply this one. You'll be getting the calculation. But see, but if you want to calculate the accurate density on what condition the air is entering into the desiccant wheel, just consider that situation. That density you have to find, because before and after the cooling coil, because if you want to find the density, entering density and leaving, two states we are having. Each state we will be having different density. As a normally we will be considering this value only, that is fine. But if you want to accurately find the density of air, which condition we have to consider? Entering condition or leaving condition? On what condition the air is entering into the desiccant wheel, that you have to consider. Okay, means the coil entering condition. But we are not having any term that is directly representing the density from the psychrometric chart. Rather, we are having a specific volume. From the psychrometric chart, we can find the specific volume of entering condition. Take the reciprocal of specific volume, we can consider the density of air. Okay, so density of air, if you want to find outside condition, is this one only. And what is the specific volume of this condition? See, this one and this one is the specific volume lines only. Those guys, they're not having the idea regarding psychrometry. I have already explained. I have uploaded videos in our YouTube channel. You can watch it. Those videos are free of cost only, I guess. Okay, this is 0.9 and this is 0.91. Okay, this is 0.92. So this is coming between 0.90 and 0.91. So that will be 0.901, 0.902, 0.903, 0.904 or 0.90. Say 0.904 we can consider this one. It's not exactly on the middle. If it was on the middle, then we can consider 0.905. The specific volume we are getting 0.904 only. Consider that one. Specific volume at entering 0.904. Okay, meter cube per kilogram. Okay. Fine. You can see the unit here, cubic meter per kilogram of dry air. Okay. And now we can find the density. Density of air is equal to mass by volume. Okay. Mass is equal to volume into density. So if you want to find the mass, we need the volume. We are already having the volume. Now we need the density. Density is equal to, density is the reciprocal of specific volume only. Now 1 by specific volume is density. So just find it. Density of entering condition is 1 divided by specific volume. This one, 1.106 kilogram per meter cube. See, even if you are considering 1.2 kilogram per meter cube as a common, no problem. It's not a big issue. Not that much changes will come. But just I have considered the entering condition specific volume for accuracy. Okay. Now I can find the mass of air is equal to volume of air is this one in meter cube per second into density. correct? Mass of air is equal to volume into density. I got it. So we are dealing with nearly 1.09 kilograms per second of air. Each second, 2100 CFM is equal to 1.09 kilogram only. Now the water to be removed is equal to mass of air into humidity ratio at entering condition minus humidity ratio at leaving condition. So we know mass of air is this one into humidity ratio at entering condition is 21.5 minus humidity ratio at leaving condition is 9.3. So 13.37 grams per second. Grams per second. Each second, this much gram, because you can see this is 12.2 grams only. This is in kilogram per second. Correct. You can check the unit. Mass is in our case, mass is in kilogram per second. Humidity ratio is in gram per kilogram. So the final unit will be gram per second. If you want to convert that gram into kilogram, grams per second divided by 1000, you will be getting that in kilogram per second. Kilogram per second, if you need in like a kilogram per minute, kilogram per second multiplied by 60, kilogram per second multiplied by 60, you can convert that into like kilogram per minute. And if you need that in kilogram per hour, kilogram per second into 3600 or kilogram per minute into 60, 48 like kilogram per hour. Okay, so each hour 48 kilogram, or for water is a standard fluid, 1 kilogram of water and 1 liter of water is same. So that is 48 liter per hour or 48 kilogram per hour of water has to be removed to achieve the condition. So that's why when you are selecting your dehumidifier coil, whether there is a coil based system or if it is a desiccant wheel based system, the capacity is this only. So whatever the capacity it may, you can, whatever the unit it may, if you want to convert that into pound, as per your convenient unit, you can convert it. Okay, so that's a very easy calculation. If you know the entering and leaving condition, you can easily find the desiccant wheel. But the diameter of the desiccant wheel, how much pressure drop is going to happen within the desiccant wheel, those data, unfortunately, we are not having any direct options to calculate it. Those data we will be getting from the manufacturer only. We'll be getting a technical data sheet as per our requirement, entering condition, leaving condition. As per our requirement, we will be selecting the right model from the manufacturer data, the diameter. Okay. But we need to, most of the cases like a dehumidifier, we will be selecting with respect to the amount of water has to be removed or condensed. Okay. Now how the process will happen? For example, if it is a coil based system, a cooling coil based dehumidifier system, you have to cool the air. Correct. If you're having a cooling coil, so even if we are having the room temperature of like 24 degrees Celsius, what will happen if we kept the coil temperature like 24 degrees Celsius? For example, this is 20, 21, 22, 20, 21, 22, 23. This is 24. Okay. So when you are cooling the air, the relative humidity will increase. When you are heating it, the relative humidity will decrease. Relative humidity is increasing means the water carrying capacity of the air will decrease. The water holding capacity will decrease. For example, when you are cooling the air from 60% to 70%, or sorry, when you are cooling the air from like 35, 34, 33, 32 degrees Celsius, nearly, relative humidity will be increasing from 60% to 70%. When you are cooling, the relative humidity will increase. Until the relative humidity is 100%, the water is not going to be condensed. Correct. Because 70% relative humidity means there's still 30% of space is remaining. It will not condense, right? That's why, again, if you want to cool it, you have to cool it until this point. So once the saturation point has reached, once the 100% relative humidity point has reached, now the air is having the maximum quantity of water vapor in it. Still, if you are cooling it, the condensation starts. That point is called DPT, or dew point temperature. It's a temperature that is recorded by the thermometer in which the moisture that is present in the air will start condense. So that's why for 35 degrees Celsius dry bulb temperature and 60% relative humidity. See, just understand 35 dBT, 60%, the humidity ratio is 21.5 gram only. Okay. Now this is 35, 34, 33, 32, approximately 32 point something. Let's say 32.2 degrees Celsius and 70% relative humidity. Let's say 32 degrees Celsius and 70% relative humidity. What humidity ratio? Humidity ratio is same only. So that's why humidity ratio remains same for various states. Even if the dry bulb temperature and relative humidity might be different, it may having the same humidity ratio. Humidity ratio might be same for various states. Okay. Anyhow, you have to cool the air until this temperature, then only the condensation will start. What temperature it is? 25, 26. So once 26 degrees Celsius has reached, the condensation start. So if it is a coil, you need to keep the surface temperature of cooling coil less than 26 degrees Celsius. But as you know, if the room temperature is 24 degrees Celsius, if you kept it 24 degrees Celsius, what will happen? Okay, it will be cooling. This is 25, 24. Okay, the condensation will start at 26 once it has reached 24 degrees Celsius. Okay, what about the relative humidity ratio in that state? It might be 18, 18.5, nearly 19 gram only. We have to condense the water from this point to this point. But if you are keeping the surface temperature of cooling coil, we can cool the air only up to 24 degrees Celsius. So effective condensation is not possible. We can't remove the air from 21.5 grams to our requirement. Only this quantity we can remove. So that's why if we want to remove the humidity ratio until this point, you should keep the surface temperature of cooling coil here, nearly up to 13 degrees Celsius you have to keep. So the room you need 24 degrees Celsius, but the surface temperature of cooling coil you require to keep 13 degrees Celsius. That is waste of energy. No? A lot of cooling load has to be increased in your very less temperature you need in the. Still we are considering the apparatus. This one, no, sorry, bypass factor and all. When you are considering ADP, no, apparatus dew point temperature might be still less than this one. That's a disadvantage of a cooling based system, because if the relative humidity requirement in the spaces are too less, the surface temperature of cooling coil we need extra, like less than 13, 10, 5 and all. So that is waste of energy. No, it is not that much energy efficient system. Okay, that's a disadvantage. Instead of that, if you are using a desiccant wheel there for high capacity industrial applications and all, so if you are having a cooling coil and if you are having a desiccant wheel, and anyhow, the leaving condition we need 24 degrees Celsius only. See, this humidity removal, these things will do. Means the air will be entering into the desiccant wheel. This is a desiccant wheel only at a humidity ratio 1. Means like a 21.5 gram. When it is leaving, it might be like a, let's say 9.4 gram. So humidity removal has already happened by the help of like desiccant wheel. Then we don't want to keep the surface temperature of cooling coil like a 13 degree and all. Even if you are keeping your surface temperature like a 22 degrees Celsius, anyhow, if you need 24, the supply temperature should be slightly, or the coil surface temperature should be slightly less, because no coil is having 100% efficiency. So that's why you can keep like 22 degrees Celsius and all when it is leaving. But this we have to calculate. When it is leaving, the condition we will be receiving 24 degrees Celsius. The advantage, since the desiccant wheel is removing the humidity required, the coil surface temperature we don't want to keep like a 13 degrees Celsius and all. So if you are using a chilled water system, then the chilled water temperature we don't want to make us loss. So that is energy efficient. Correct. So that's advantage for heavy industrial applications and all. Desiccant wheel, if you are using like we will be using a cooling coil, but the cooling coil surface temperature we can keep like higher, means somewhat near to the room space dry bulb temperature. See, even if that's a desiccant wheel, the water it has, correct, it might be accumulated on the surface of silica gel and all. We need a regeneration, means we will be heating the air by the help of hot air technology or steam or electrical heater we might be having. So it will be heating the air. So the air molecules will be vaporized and it will be evaporated. Correct. So that's why a regenerative or regeneration system should be also supported with the desiccant wheel to remove the water it has absorbed. Clear. And this is not exactly the hybrid system. Hybrid system, for example, initially we will be having a cooling coil. For example, if the supply temperature that we required is 24 degrees Celsius, okay, as per the site condition, we might be keeping the surface temperature of cooling coil like a 22 degrees Celsius. Anyhow, okay, in that scenario, from humidity ratio 1 to 22 degrees Celsius. Anyhow, if you want to cool the air until 13 degrees Celsius, until humidity ratio 2, okay, then you have to cool it up to 13 degrees Celsius, correct? If you need to achieve the humidity ratio 2, we have to cool it until 13 degrees Celsius. But as per the space criteria, I need 24 degrees Celsius. So the surface temperature of cooling coil, let's say it might be 1 or 2 degrees Celsius less than the space criteria. So the air will be entering at a humidity ratio 1, and the dehumidification will be happening up to this point, means around 26 degrees Celsius it will start, but the surface temperature of coil is like a 21, 22. Up to this point, the dehumidification, the coil will take care. Correct. If you're having a cooling coil, okay, and the surface temperature of cooling coil is like a 22 degrees Celsius only, it will be entering at a humidity ratio 1, means 21 grams or 21.5 grams of water will be there. And since the surface temperature of cooling coil is 22 degrees Celsius, up to this point, humidity ratio 2, that's or we can consider this as a humidity ratio 3 point, and this is a required humidity ratio 2 point. And that is nearly 16.5. Up to 16.5, the coil will remove. Because we don't want to keep the surface temperature of cooling coil too less as per the space condition. Space we need 24 degrees Celsius only. But still, it has not reached humidity ratio of required condition. Excess humidification still we required. There, after the cooling coil also we can propose a desiccant wheel. So that's why now this desiccant wheel has to remove the humidity from this point to this point only. The entire dehumidification is not mandatory, or it can means up to this part the cooling coil will take care, remaining desiccant wheel. So that's why the location of this is called hybrid system. The combination of cooling coil, the dehumidification should be happened by the help of cooling coil plus a desiccant wheel, combined system. We used to call that as hybrid system. So in hybrid systems and all, after the most of the cases, no, the desiccant wheel or the dehumidifier will come before the cooling coil only. But in hybrid system, it can come after the cooling coil as well to make the machine. Why we are doing this? To make the machine more energy efficient. We don't want to keep the surface temperature like less than 13 and all. That's advantage. Okay. Anyhow, this one, this calculation is slightly different. I will be explaining this in the next session. Okay. Hope it is clear, everyone. Thank you.